You wake up, and a sharp smell of rotten eggs hits your nostrils. You look around wildly and realize the smell isn't coming from your mom's cooking downstairs. It's super hot, and there are giant red clouds churning in the sky. Yikes! You're on Venus! The planet is named after the ancient Roman deity of beauty and love, but sadly, its smell doesn't correspond with its name. The atmosphere of Venus is made up mainly of carbon dioxide, but thick clouds of sulfuric acid completely hide its surface from prying eyes. Sulfur has a really bad stench, which causes the surface of Venus to smell like rotten eggs. Gross! The atmosphere on the planet is also really hot and thick. The carbon dioxide traps a small amount of energy from the sun that reaches the planet's surface. This greenhouse effect has made Venus one of the hottest places in the solar system. So, the good news is, you wouldn't be able to smell the planet's stench, as humans can't survive on its surface. Well, that's a relief. Almost all other planets in our solar system only have a super small selection of different scents on their surface, unlike Earth. But what about our moon? The scent of the moon is similar to something called smokeless powder, which is a propellant used in firearms. Basically, the dust on the satellite smells exactly the same as when a shot is fired. Apollo 17's pilot Eugene Cernan says he could smell it straight after removing his suit from the spacecraft. But nobody's exactly sure why it smells like this, as there's zero similarity between the two substances. Smokeless powder is made up of a mixture of two things with very complicated names: nitroglycerin and nitrocellulose. Black powder, its older counterpart, is made of charcoal, saltpeter, and sulfur, which makes it smell in a very specific way, but not like rotten eggs, despite the sulfur content. Moon dust is made up of a bunch of things that primarily come from broken meteorites. This includes iron, magnesium, and calcium, but it doesn't contain either of the things in smokeless powder, or black powder either for that matter. And what's weirder is that moon dust samples brought back to Earth have been odorless. Experts say the smell could have been the dust reacting with oxygen or water inside the lander. The smell could also be due to the temporary release of charged particles from the sun that had become trapped in the dust. Mercury is the planet closest to the sun, but it doesn't really have a strong smell. This is because the atmosphere is so thin and scattered. Mars. Like Venus, it's another world that doesn't have the best scent ever. It's a good thing we can't breathe its air. The red planet smells like rotten eggs, again caused by sulfur. If human colonies did move to Mars, it looks like we'd have to burn a lot of scented candles to cover the smell. But the good news is that the sulfur quantities are pretty small, so the smell wouldn't be too overwhelming. Jupiter also has a whiff of eggs, but also smells a bit like it's been mixed with cleaning products. This is because its atmosphere is a mixture of hydrogen sulfide and ammonia. But what you smell basically depends on where you are in the planet's atmosphere. Some regions have higher concentrations of ammonia. This substance is used in a bunch of cleaning products here on Earth. So areas high in ammonia could have that strong burning stench of cleaning fluid. A lot of people also say that ammonia smells like a pair of dirty socks that haven't been washed in forever, so it's for sure best to avoid these parts of the planet. Other areas have a lot of hydrogen sulfide, and because it contains sulfur, these parts would also smell like rotten eggs. The third and final scent you'd find on Jupiter is bitter almonds, or marzipan, just like the kind your grandma puts on cakes around the holidays. This is in areas where a substance called hydrogen cyanide is most common. Jupiter is the biggest planet in our solar system. It's so big that it's 2.5 times larger than all of the other planets in the solar system combined. It's also the fastest spinning planet in our solar system. Next up, the ringed planet, Saturn. Its atmosphere is made up of about 96% hydrogen and 4% helium. Yes, that's the gas that makes your voice go all squeaky. Both hydrogen and helium are odorless, so Saturn probably doesn't have a strong smell. It does, however, contain traces of our good friend ammonia. That's the smelly sock gas. Saturn's atmosphere also has a bit of phosphine, which can sometimes smell like garlic or decaying fish. So there might be a slight bad stench in the air. The thickness of Saturn's atmosphere is only 37 miles. For comparison, our atmosphere here on Earth is almost 300 miles thick. Saturn also has some of the strongest winds in our solar system. They can reach a whopping 1,118 miles per hour. One of Saturn's moons is called Titan, and it has a super odd scent. Its atmosphere is made up of something called benzene, which has really weird effects if inhaled by us humans. It can make us feel dizzy and make our ears ring. It doesn't actually smell that bad though. Its scent is kind of like almonds. Now it's time to take a dive into Uranus. This gas giant has gotten itself a reputation as the smelliest planet in the entire solar system. There's a lot of stinky stuff floating around on the planet, and its upper atmosphere is made up mostly of hydrogen sulfide. Yep, that's the molecule that makes rotten eggs smell so nasty. But the temperatures are so severe on Uranus that you'd pass away even before you've had a chance to smell anything. Uranus's atmosphere is a staggering negative 392 degrees Fahrenheit. That's so cold that it would almost instantly freeze anyone. The final planet in our solar system is Neptune, and it's just as cold as Uranus, at negative 373 degrees Fahrenheit. Neptune also smells pretty bad. Some scientists say it smells like seaweed that's washed up on the shore. Others say again that it smells like rotten eggs, because it contains a bunch of hydrogen sulfide molecules. But like on Uranus, you're not going to have time to take in the nasty smell. As the most distant planet from our sun, it's dark, freezing cold, and has supersonic winds. No one would be able to survive when faced with one of the icy hurricanes which are constantly raging on the planet. Neptune is the only planet in our solar system that's not visible to the unaided eye. Well, we've covered the planets, but what does space itself smell like? Space is mostly a vacuum, which means it doesn't actually contain any molecules, so there's basically nothing to smell. But some astronauts have actually said space smells a bit like fried meat or hot metal. This smell is most commonly reported in the first instance after the astronauts re-enter their spacecraft. They shut the airlock, repressurize, and then remove their helmets. But there are a bunch of theories suggesting that the meat smell isn't actually space. It's either from the equipment operating the airlock or from interactions between space particles and the spacesuits. Astronaut Tony Antonelli said that space definitely has a smell that's different than anything else. Talking about his fellow spacewalkers coming into the ship, another astronaut, Don Pettit, said he noticed that this smell was on their suit, helmet, gloves, and tools. One thing we definitely know that has a smell, though, is comets. If you could inhale a big whiff of a comet, it's likely going to make you feel lightheaded and maybe even sick. The odor from comets is like a mix of rotten eggs, old smelly socks, almonds, and it'll also have a hint of biology dissection lab. On the bright side, though, the presence of hydrogen sulfide and sulfur dioxide in the scent would block your sense of smell after the first sniff. So at least the stench wouldn't linger. But the bad news? Nearly all the ingredients that make up a comet's smell are toxic. So you're probably going to want to avoid coming into contact.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the Moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the Moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the Moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire Moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the Moon's surface and its core, called the mantle, has been moving around as the Moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the Moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the Moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the Moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the Moon's magnetic field. Knowing what the inner core is like can help us better understand the Moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the Moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the Moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
You take a rocket to the moon. It lands. You put on your work uniform and go to work your shift at a local factory that extracts water from beneath the surface of the moon. There's also fuel plants here. Dozens of people and rovers are roaming the expanse of Earth's natural satellite. When your shift ends, you board the rocket again. It takes you back home, just like a regular bus. That's exactly what NASA is planning to do. In the first stage of this project is the Prime 1 mission. Prime stands for Polar Resources Ice Mining Experiment. The mission starts in 2022. Let's follow it step by step. A booster rocket and second stage are assembled on the launch pad. Ignition. The rocket's engines begin to burn fuel, and we go up. Soon, the rocket reaches a speed of about 24,000 miles per hour. At that speed, you could travel the distance from New York to London in just 8 minutes. Once the booster uses up all its fuel, it undocks and makes a soft landing on Earth. The second stage with the payload capsule fires its engines a couple of seconds after the first stage undocks, so the rocket continues moving up. Once it reaches orbit, the payload capsule opens. It releases the lunar lander Nova-C. It's a cylindrical spacecraft, as long as a sedan and slightly wider than the height of the average person. It starts its engine and begins its journey. First, the lander makes a circle around Earth. This is a gravitational maneuver that helps it to gain speed without wasting too much fuel. Because the lunar lander is still in orbit, Earth's gravity affects it. The spacecraft looks as if it's falling, but not to the surface of our planet, along its orbital trajectory. After one lap around Earth, the lander adjusts its trajectory and heads for the moon. The distance it needs to cover is 238,600 miles. That's like 9.5 trips around Earth, or 93 trips across the United States from coast to coast. Modern spacecraft can cover this distance in as little as 9 hours. That's a bit more than a journey from New York to Los Angeles by plane. At the same time, it took the first astronauts about 72 hours to get to the moon. Soon, Nova-C is near its destination. It makes another circle around the moon while it descends. Scientists have already chosen the perfect plane for it to land. There are several requirements. First of all, there should be signs that there might be ice under the surface in this location. Second, the lunar module should be able to maintain radio communication with Earth. And this is impossible if the lander is on the far side of the moon. When the first astronauts flew around Earth's natural satellite, contact with them was lost for a few minutes. The connection only resumed when their spacecraft came out of the lunar shadow. And the last requirement for the landing area is sunlight. The lander has solar panels to power its scientific equipment, onboard computers, and communication modules, so it needs direct sunlight. The lander is getting closer to the surface of the moon. The spacecraft is slowing down as it approaches the landing site. Now, it's almost hovering in midair. A few more seconds, and touchdown! The spacecraft makes a soft landing. It's time to drill through the surface. For this, the lander has a device called the regolith, an ice drill for exploring new terrain. To put it simply, it's a large, 3-foot-long drill. That's almost as long as a grown-up person's leg. Once the right spot is chosen, the device gets lowered into the lunar soil. Drilling will have several stages. Lander will have to lift the drill several times to get the soil out of the drill hole. Otherwise, it may damage the drill bit. Next, the lander will have to analyze the soil composition. To do this, it carries a mass spectrometer, observing lunar operations. Shortly, M-SOLO. Its work is based on a simple principle. It ionizes or charges particles of soil, making them move. Then it creates a strong magnetic field, which affects the charged particles, making them change their trajectory. Different substances, their molecules, and atoms move differently in the magnetic field. So, by analyzing the changes in their trajectories, we can identify the mass and charge of each particle. All we need to do next is look at Mendeleev's periodic table and see which atoms we can find in the samples. Scientists hope to find H2O, water. The south pole of the moon is an ideal place to keep ice within reach of our drill. The equator would be a great place to maintain radio contact and power the solar panels of the lander, but this area is likely to be too hot to have any ice. The lander will also carry a lunar hopper. This thing will be used to explore the surface of the moon. It will carry a load of about 2 pounds. Scientists will also test 4G communication technology. The lander should have some special modules for this. If the test is successful, people might be able to use cellular coverage for communication on the moon, like we do on Earth. But the main goal of the mission is to prove that the resources found on the moon can be used in the future. As early as 2023, NASA plans to send an autonomous rover called Viper, which stands for the Volatiles Investigating Polar Exploration Rover, to the moon. It'll land at the moon's south pole for the same reasons: the connection with Earth and sunlight. The rover itself will be about the size of a golf cart. It'll carry a drill and soil analyzer. Scientists have already laid out a route for the rover. It's about 10 to 15 miles long. It'll take Viper 100 days to travel along that route. It'll drill the soil in search of lunar ice and mark its findings on the map. It will be necessary to prepare for astronauts' arrival to the moon. It'll also help to provide them with valuable resources, like water. Later in the 20s, NASA will launch the Artemis mission. For this purpose, scientists have been constructing the Orion spacecraft for decades. It can carry 6 astronauts. The launch vehicle that will take Orion into orbit is called the Space Launch System. When ready, it'll be the most powerful rocket in human history. The first flight will be uncrewed. It's scheduled for 2022. Like the lunar lander, the spaceship will ascend into orbit, make one revolution around our planet, and go to the moon. Once it reaches the satellite, it'll stay in orbit for 6 days and then return to Earth. It'll spend a total of 25 days in outer space. The second mission is planned for September 2023. This time, we'll send 4 astronauts to the moon. They will fly around Earth's natural satellite and return without landing on the lunar surface. This will be the first crewed mission to the moon since 1972. The third mission, Artemis 3, is scheduled for the 55th anniversary of the first lunar landing in 2024. 4 astronauts will travel to the moon's orbit. Once there, 2 of them will move to the Starship HLS. This is a new lunar lander designed by SpaceX. Then they will make a soft landing on the moon's surface. The astronauts will spend several days there. Then the lander will fly back into orbit, dock with Orion, and return to Earth. There's also plans to build a space station in lunar orbit, the Lunar Orbitable Platform Gateway. It'll be almost like the International Space Station. It'll be assembled from a lot of modules, just like the ISS. There will be a power and propulsion element. This is going to be the first module equipped with engines for maneuvering and propulsion. There will also be solar panels that will power the station. One more module will serve several purposes, including communication and refueling. Then, there will be several living modules. They will be able to host several astronauts for a period of up to 90 days. That's where they will eat, sleep, train, and conduct scientific experiments. The station will be equipped with a robotic arm. It'll help spacecraft dock with the station, as well as install additional scientific equipment outside the station. There will be an airlock module. Incoming spacecraft will be able to dock with the station there. It'll be like a parking lot for dropping off and picking up passengers. Astronauts will be able to use it as a door to outer space. There will be a sample return vehicle, a small spacecraft, that will deliver samples of lunar soil to the station. It'll be fully robotic. The Gateway will be much smaller than the ISS. For comparison, the near-Earth station now consists of 11 modules, and its total cost is about $150 billion. In the future, we'll use this station as a launch pad to send spaceships to other planets, like Mars, or into deep space. Rockets launched from the ISS will need much less fuel, because they won't have to fight Earth's gravity. But the astronauts on the Gateway will be in more danger than on the ISS because of radiation. Earth's magnetic field acts as a shield that disperses the sun's harmful rays. And astronauts staying there don't get much more radiation than the passengers of a commercial airplane on Earth. The moon is too far from our planet's magnetic field, so all the modules of the Gateway station will have to be additionally protected from solar radiation.